So this is day 2 of transitions. Today what we're going to do is we're going to look at prime numbers. Going back to your elementary days, maybe you remember factor trees. That is one way of figuring out prime factorization. But we're going to look at prime, what it means to be a prime number. Alright, so when you are dealing with a positive integer, those positive integers can be factored many different ways. Let's take the number 12 for a moment. If you think about 12, you can factor that as 1 times 12. You can factor that as 2 times 6. You can factor that as 3 times 4. The factors of 12 are the 6 positive integers, 1, 2, 3, 4, 6, and 12. Positive integers like 12 with more than 2 factors are what we call composite numbers, right? So, definition here. To be composite, it would have more than 2 factors. Okay? More than 2 factors. Now, let's take a different number. Let's say I want to look at the number 7. Thinking about how I could factor 7, 1 times 7. If I run through my other numbers, there's no other way for me to factor or to split up the number 7, except 7 times 1 or 1 times 7. So the factors of 7 are 2 positive integers, 1 and 7. Positive integers like 7 that have exactly 2 factors are what we call prime numbers. Alright? So prime numbers have exactly 2 factors. Okay? They have exactly 2 factors. So let's just look at this for just a second. Let's just say that the question asked you to find the factors of different numbers. Alright, so let's look at the number 36 for a moment. So I'm going to tell you the best way for you to do this is just to start with what you know about the number 36. I know that I can multiply 1 times 36. I know that I can multiply 2 times something because if you remember, any number that ends in an even number can be divisible by 2. Alright, so 2 times 18 is 36. Alright, 3 times 12 is 36. 4 times 9. I just run through my numbers. 5 won't go into it. Alright, 6 will. So I have 6 times 6. So when it asked me to find the factors, I found my factors. Now I'm just going to list them. And the best way for you to do this is to list them in order. So come over here and write your list. 1, 2, 3, 4, 6. I do not have to write 6 twice. Once I write a number, I don't write it again. 6, 9, 12, 18, 36. That is the complete list of factors for 36. What if I have the number 1? Think about that for just a second. What if I have the number 1 and it says list the factors for the number 1? only thing I have is 1 times 1. No other number will go into the number 1. The reason I'm showing you this one is because I want you to see something. Now, if I list the factors of 1, it's 1. How many factors are there? There's only 1. Go back up to our definitions here. Composite says to have more than 2 factors. Does 1 have more than 2 factors? No. The definition of prime is having exactly 2 factors. Does 1 have 2 factors? No. It only has 1. So therefore, we would say that 1 is neither prime nor composite. Okay? It is neither prime nor composite. All right, so here's what we find when we are dealing with these factors. We see that any positive number greater than 1 can be written uniquely as the product of powers of prime numbers. So this product of powers of prime numbers is what we call our prime factorization. Okay? That is what we call the prime factorization. Once again, this is where those factor trees led to, if you ever did a factor tree. It led us to the prime factorization of numbers. So let's consider a couple of examples. Let's think about the number 12. Okay, we've already factored out 12. We factored it into 1, 2, 3, 4, 6, and 12. But here's the key word to this part, prime. That means we want to get everything down to prime numbers. We want to know what is it factored at as prime numbers. Guys, you can do this a couple of different ways. I'm going to tell you the factor tree to me is probably the simplest way to do this lesson. Okay? So I'm going to take, and I'm going to factor that 12. So I want to think about, what do I know that will go into 12? You do not want to start with 1 and 12 because that gets you nowhere. You are no closer to the prime factorization if you start with 1 and 12. So you can start with 2 and 6, you can start with 3 and 4, it does not matter. One may be quicker than the other, they may take the same steps, but just think about what are some numbers that go into 12. So let's say that I want to start with 2 and 6. This is where I have to know the definition of prime. I want to know, is 2 a prime number? Well, the only thing that will go into 2 is 1 and 2. So it has 2 factors, so 2 is a prime number. So I'm going to circle it. I circle it because that tells me it is as low as it will go. I cannot break that number down any more than 1 and 2. Looking at 6. 6 is not prime because 1 times 6, 2 times 3. So there are 4 factors of 6. So I've got to break that down even further. Once again, I don't want to break it into 1 and 6. That gets me nowhere. So I'm going to figure out what else goes into 6. 2 times 3. We've already determined that 2 is prime, so I'm going to circle that. Now I got to look at 3. Is 3 prime? Well, 3 is only broken into 1 and 3. Nothing else goes into it, so 3 is prime. I am finished. I have nothing else that can be broken down. My tree ends. I am at all prime numbers. So I can say the prime factorization of 12 is 2 times 2 times 3, or 2 squared times 3. Now, let's check that out and see if it's true. 2 squared, that means 2 times 2. 2 times 2 is 4. 4 times 3 is 12. And that's my original number. Okay? All right. What happens when I have big numbers? Sometimes we get big numbers, guys, and it can be confusing. Here's what you've got to remember. Any number that ends in a 2, 4, 6, 8, or 0 can be divisible by 2. Sometimes you may need to get a calculator out. Calculators aren't going to give you prime factorizations, but they can help you figure out what numbers go into your number. All right? So let's do another example. Let's take the number 180. That's a bigger number. Couple of things I want you to remember. It ends in a 0, which means I know that 2 will go into it. So 2 times something. It ends in a 0, so I also know that 5 will go into it, because anything that ends in a 0 or a 5 is divisible by 5. It also ends in a 0, so I know that 10 will go into it. You've got a couple of different ways to go here, however you want to do it. I'm going to do 10. So I've got to figure out 10 times what gives me 180. Well, if I look at that, 10 times 18 gives me 180. Now I'm going to ask myself, is 10 and 18 prime? Once again, guys, let's start with 10. 10 ends in a 0. 2 will go into it. 5 will go into it. It's not prime. So I have to break it down even more. 1 times 10 is not going to help me. 2 times 5. Go back to the problem before. We determined 2 is already prime. So I'm going to circle it. Let's think about 5. 5 times 1. Nothing else will go into it. It has 2 factors. 5 is prime. Okay? Let's think about 18. 1 times 18. 2 times 9. 3 times 6. Notice there's more than 2 factors, so it is not prime. So that means I have to break down the number 18. So I can do it a couple of different ways. I can do 2 times 9. I can do 3 times 6. Either way, it's not going to matter. You're going to see that you will end up with the same thing whichever route you decide to take. All right, so I'm going to do 2 times 9. We've already determined that 2 is prime. So I'm going to circle that. Let's look at 9. 9 times 1, 3 times 3. It's not prime. So I've got to factor that down again. 3. 3 times 1. Nothing else will go into it, so it is prime. So if it's asking me the prime factorization, then I need to list every number that I have circled. So the prime factorization of 180 is 2 times 2 times 3 times 3 times 5. Or 2 squared times 3 squared times 5. You may see it written either way. More at the high school level, you're going to see it written this way. You're going to see it as the 2 squared times 3 squared times 5. Okay? Guys, remember, if there's any questions as you're going through this video, you can comment below in the Google Classroom. You can jump on our Zoom meetings on Monday and Wednesday. If you're not comfortable on a Zoom meeting with other class members, get a hold of me. We'll schedule a one-on-one Zoom meeting. Or we're going to get to the point that we are going to be able to schedule some one-on-one in-person appointments. Of course, you'll have to do the masks and stuff like that. But guys, if you have questions, don't hesitate to ask. Let's go just a little bit bigger. Let's look at this number. Because you know you're in high school, so therefore you're not going to get the nice little tiny numbers. You're going to get these big numbers. So once again, you've got to look at this, and you've got to go back and you've got to think, okay, first of all, I've got to figure out, is this a prime number or not? The nice thing is this one does end in a 2, so you know it's not a prime number. You know that 2 will go into it, 2 times something. So 1 times 6,552, and 2 times something will go into it. So I can go ahead and divide that by 2. So 2 times, all right, which would be 3,276. Okay? And guys, once again, if you need the calculator to help you figure that out, that's fine. This is one of those numbers that I don't expect you to be able to ramble it off of the top of your head. Now, if we're looking at the number 81, I would expect you to be able to, as high schoolers, know that 9 times 9 is 81. Then I can break those 9s down. But this number here, it's going to require a little bit of thinking or a little bit of work or a little bit of calculator use. That's fine. I already know that 2 is a prime number. So now I've got to look at 3,276. Once again, it's divisible by 2. So I've got to break that down. And that's going to be 1,638. Okay? 2 is already prime. Looking at 1,638. It ends in an 8, so I know that it's divisible by 2. If you want to sit and figure out other numbers, you can. But we're just going to kind of use this method right now. So 2 times 819. 2 is prime, so I'm going to circle it. Notice I'm circling my prime numbers every time so I can keep track of them. All right, let's look at 819. It does not end in an even number, so it's not divisible by 2. But just because it's not divisible by 2 doesn't mean that it's a prime number. There are rules to know if it's divisible by 3, to know if it's divisible by 5, by 6, by 10. It is not divisible by 5. It is not divisible by 10. Because remember, to be divisible by 5, it has to end in a 5 or a 10 or a 0. To be divisible by 10, it has to end in a 0. Go back and remember, I don't know if you were taught the rule of knowing if it was divisible by 3. If I can add the digits, so 9 plus 1 is 10, 10 plus 8 is 18. 18 is divisible by 3, so that means that 3 will go into 819. Alright, so 3. Alright, and that is, let's see, 273. Alright, we know that 3 is a prime number. Now we've got to deal with 273. It's not divisible by 2, by 5, or by 10. Let's see if it's divisible by 3. So 3 plus 7 is 10. 10 plus 2 is 12. 3 will go into 12, so this is divisible by 3. That would be 91. Okay. Let's look at 91. 91 is not divisible by 2. It's not divisible by 5. It's not divisible by 10. 9 plus 1 is 10. 10 is not divisible by 3, so 3 will not go into it. Now, guys, there are other numbers there that we don't have rules for. There's no real true rule for the number 4. There's no real true rule for the number 8 or 7. So you just have to kind of look at those. 91 is actually divisible by 7. And that would be by 13. 7 times 13. 7 is prime, and 13 is prime. So we have finished our prime factorization. That prime factorization is 2 times 2 times 2 times 3 times 3 times 7 times 13. Or like I said, as high schoolers, you're going to see it more written like this. 2 cubed times 3 squared times 7 times 13. If you want to check that, then what you can do is you can pull out your calculator and you can check to see if your prime factorization is correct. How do I do that? Well, I would take 2 times 2 times 2 times 3 times 3 times 7 times 13, and it gives me 6,552. Okay? So I know that my prime factorization is correct. Prime factorization just takes a little bit of work, but guys, it's not extremely difficult. You're going to work on some problems. I would suggest you do it on a separate sheet of paper. If you would like to do prime factorization a different way, if you've been taught how to do it a different way, you may do so. I just think that factor trees are the easiest because it allows me to see step by step how to factor this number. It's up to you. Do as you would like. Once again, remember, you need to make sure you show me your work. Guys, if you have any questions, please feel free to get in touch with me.